I have a title, apparently, and it's about tangibility. The title is big, but then the presentation is big. I'm going to play the game how many slides I can fit in 15 minutes. How much slides do you think I have?
32.
60.
100, yeah.
80.
Wow.
142.
I have like 98 slides. I don't know why, but I have 98 slides. Probably I'll cover 10.
Why not 100?
We'll see. Quite ambitious. So this is more or less my personal journey, which is partially technical, partially musical. The topic of tangibility in electronic music, and how the title is how we can turn data into haptic, real musical instruments, and how we can, not Turing, turning is the title, data into haptic virtual musical instruments. I work in Cardiff in the art school there. I'm senior lecturer in Sonic Arts and Art Science Technology. Yeah, and I have 100 slides, and I also have many videos. I don't know how I'm going to do with this, but you need to see this video because it helps. I think you got the idea. Mr. Bean is very expressive, right? Extremely expressive, even without a keyboard. Nobody can do that. Probably he's the only guy who can do that. So, as a musician, I'm mainly a classical guitarist, and I'm very extremely interested in tangibility and the feel that the musical instruments have. It's very important for people who are playing acoustic instruments, I think. So, this is the basic story, that when you play a musical instrument, of course you have a mechanical excitation taking place with the object, and then you have the auditory feedback, and then you have the visual feedback, which the better you become in your instrument, you don't actually watch when you play. It's like dancing, you don't watch your feet. And the haptic feedback, which is my main interest. So I'm very interested in haptic, and yesterday I updated my system, and I realized that haptic feedback, even pages like the Mac, the new Macs now support haptic feedback. Something that I've been working the last 15 years. So it's becoming an important modality nowadays. I have a background now about digital musical instruments. I think you need to read that, but that's the main. As we all know, the main idea is that you have some transducers here. There is some type of conditioning here and a mapping stage where you map your gestures into signal-based or whatever, or music processes. And that's the main paradigm. And as an output, you have feedback. You can see, of course, the interface, but also you feel. There is a haptic field, but the haptic field is coming from the transducers, which are decoupled from the actual system that makes the music. So it's quite artificial, but people master it like pretty well. But there is another paradigm which I'm much more interested. Before talking about the other paradigm, I will go back to this later. It's that programmability is an interesting issue in computer music, and now we can have a programmable mapping scheme. The sound engine can be programmable. What we not program maybe yet is the physical interface, but I will come back into it. So that's more the common scenario with acoustic instruments, which can be transferred in electronic music instruments. So instead of having a pilot pressing buttons, you have somebody who interacts with the system and exchanges energy. So this energetic coupling is the essence of virtuosity, I believe. And that's what I get when I play the guitar, and that's what I want to get when I play my electronic music instruments. Of course you have visual cues, but also this gesture interaction is something that's necessary. And the pioneers...
1976, Lacroix réalise son premier...
If you're not French, probably you will not get it. It's a French lab where I did my PhD 10 years ago in Grenoble, where they have been working on force feedback system for music since the 70s, like early 80s maybe. So they create those beautiful transducers and this beautiful research, but I'm more interested how the community have access to this kit. So coming back to programmability, we say that synthesis is programmable, mapping is programmable, data acquisition is quite programmable with microcontrollers and a few electronic components. The physical structure, like the physical thing that you touch, maybe not yet. So I've been working in this thing the last couple of years, and I had two questions to answer. How we can program haptic interactions, but how also can we turn data, how we can program physical stuff. So these are the two angles of my research. I will start from the second question in a very jumpy, quick way, and I'm going to talk about digital fabrication because we're living this revolution now, where we can now have computer-based tools to make stuff. And I'm not only talking about 3D printing. So the real importance here is now, in the past we had control over the information, and now we can have personal control over the construction of the work, over the stuff we make. So personal fabrication will bring programmability of the digital we invented to the physical world we inhabit. That's Neil Gershenfield, is one of the big figures. He created the Fab Lab network at MIT. We have a Fab Lab in Cardiff where I work, and it's an interconnection of labs where they claim they can make almost everything in quite a programmable fashion. So these are some techniques that you will see taking place of those labs, subtractive and additive fabrication with machines like this one, like CNC machines for making circuits, for making boards, for cutting wood, for 3D printing all that stuff, from creating molds and pouring materials to create your objects. And of course, the description file who drives all these machines, like the Rhino here thing. So FabLab is a big network where people share their ideas, share their stuff, and I want to use this network to make music and musical instruments. People have been designing, like Alex here, now he personally in FabLab Amsterdam, he's not working there anymore, prosthetics to houses, and we're talking about open design. And also people were interested in making instruments. Again, Alex created a bass guitar. People are creating mouthpieces like in the Technical University of Delft, even full saxophones, electric guitars, and even, this is an interesting case, the flute from Zoran again from the MIT lab. So where I'm taking this, that's Fab Lab Cardiff, where I tend to work quite often. It's in the same building. And we had two projects last year, which again bring tangibility in a weird, in a mysterious way. It's not a mysterious way. You can program the physics, and you can program actually the device, and let the machines make it. So the first experiment, we designed the Kaval instrument, which is a wind instrument, a Greek wind instrument with Darius Bezos, a colleague from Greece, and that's him trying to play it. This was 3D printed. It's still not electronic though. Then I took part in this AHRC funded program, and we developed, it was a big team with interaction designers and programmers, a similar idea. That tells everything in 4 seconds. I don't know if you got it, probably you didn't, but I will try to explain. So, we created the description of the instrument in the CAD, we 3D printed it, and we augmented its functionality with electronics. So now you can have an augmented digital musical instrument, but everything is coming from a single file. So you don't have to make it, let the machines make it. You're mainly the designer. These are some pictures for the CAD. This device surprisingly worked very, very, very well, and even the mouthpiece was even better from the mouthpieces that we tend to see in the commerce. And of course, it's a fully functional system where we also designed the electronics that come with it, and we started doing compositions. And we did also an application where it reads, thank you, your gestures and visualize them in order to play better. We did some user tests with people that played this in London, and the results are not published yet, but they're very positive. That's how it sounds like also. So starting from data, we made a fully functional instrument with the visualization component. A similar project, which I finished last year in ZKM in Germany, was again being interested in tangibility. I want to design an instrument that has a very physical, strong component and start performing with it. It's called Taladon, you can see it here, and it's also a multimedia show where I play also with shadows and light. And here probably the video will show us better what's happening. So this instrument has a very clear physical, strong physical presence with its dynamics, all designed on the computer, with also specific points of interaction, and I convolute my gestures, the excitation, with physical models to create a more complete soundscapes and more tight in a way, sonically and also gesturally, and I have 3 minutes. These are some, okay, this is Kandinsky, it's not me, I didn't paint this. The inspiration of the piece came from this painting. These are some sketches, and now we do the fast forward thing. We're on slide 40, I suppose. 60 slides to do with 33 minutes. So these are the descriptions. The interesting part about those projects is that we had programmable gesture acquisition systems, we had programmable digital sound synthesis, and now through digital fabrication we can program most of the physical stuff and create very interesting, haptic fields. The other type of work that I do, as I say, is programmable haptics, and I will do a quick run. And with a colleague from Louisiana State University now, he was an ex-Stanford student and PhD, we started developing a library of objects in Maximum ST, pure data, and also in flourished and other programming environment, where you can have components, put them together in a Lego style, and make easily accessible haptic interactions. Also, we designed haptic interfaces. So we use motorized fader like this one, and through physical models, it gives you the possibility to interact with the system, but in a neutral, physical, manipulative way. So you feel forces, you feel contact, you feel gravity, you feel friction, and it's very easy to program it. That's one of the versions of the fader. I'm going to skip it because we don't have the time, because I'm going to show you how, these are some design files, how we imagined it. So the interesting thing is you have a block diagram like this. You can see that the user is interacting with haptic device. The haptic device, in a bi-directional way, it has actuators and sensors. Goes back to the device and talks maybe to the mapping function, which also the mapping function talks to the synthesizer. And that's how it looks like. It looks like the block diagram. So this is the fader, actually. And you connected it with, in a bi-directional way with a spring, and you connect the spring in a bi-directional way because everything is bi-directional, because you need this feedback. It's Newton, I didn't invent this, with the ground. And also that's another force coming from the top, like gravity. And then you can scale it and map it and do whatever you like with it. So these are a few other very simple models. How much time do I have? 1? 0?
15 seconds. Yeah.
15 seconds! 40 slides in 30. I think I'm going to stop. The idea is, we started running workshops, I started making compositions with it, and the interesting bit is that you can have the tip of your fingers, I'm gonna stop, easily programmable haptics. It's just a Lego game. It's not rocket science, and I'm more interested nowadays in making music, and I have to stop now, and you have to ask me a question now. And if you want, you can meet me later to show you the other 50 slides I have.
We started slightly late, so we don't really have much time. And one quick question, perhaps, and then continue in lunch. Yeah.
I think that was very interesting. Can you tell us more about this slider that you showed towards the end? It was sort of a force feedback slider, right?
Yeah.
And you going through Max and then coming out through MIDI. Is that how does the user feel? What's the user feeling when they actually use it?
Amazing. It's amazing. No, it's no, it's
Where are you
I
placing
answered
it?
the question, right? No, you can feel forces, you can feel collisions, you can feel all that stuff. It's not very accurate, but the point we designed this system is not. Our priority was not accuracy of rendering the forces, it was more to create a tool that is easy, very, very easy to use. And everything is open, the design of the device is open, you can find it on the website, the library is open, you can expand it, and it gives another dimension to your playing. Honestly, it feels closer to nature in a way, into my guitar. Thank you. Yes?